Hello students, let us discuss the hybridization in alkanes, alkenes and alkynes. Alkanes, alkenes and alkynes are the hydrocarbons. So let us discuss hybridization in these. First of all, let us take ethane. Ethane molecule, the formula is C2H6, that is 2 carbon, 6 hydrogen. Here the central atom, that is actually carbon atom. So 2 carbon atoms are involving in the hybridization. So first of all we will be writing the electronic configuration for carbon atom. That is the ground state electronic configuration for carbon. Atomic number is 6. So 1s2, 2s2, 2p2. That is the ground state electronic configuration of carbon. Now here in the case of bonding, the inner electrons are not participating, so we will be not writing these electron. So only the valence shell electrons are participating, so we need only 2s and 2p electrons. So we will be not writing 1s electrons. Here in the excited state, one of the electron from 2s get excited to 2p orbital. So here you can see now the electrons are in the singly occupied here, that is here 1, 2, so total 4 electrons are there. 1s and 3p orbitals undergoes hybridization. So we can say that it results in the formation of 4 sp3 hybrid orbitals. 4 sp3 hybrid orbitals that having tetrahedral geometry. So here it is mentioned the tetrahedral geometry of this carbon because here 2 carbon atoms are there. So here it is tetrahedral geometry of this carbon and the tetrahedral geometry of the other carbon, because both the carbon involved in the hybridization and both the carbon is sp3 hybridized here. So tetrahedral geometry which is shown here, that is for this carbon and for this carbon. From 4 sp3 hybrid orbital for this carbon, that is 1, 2, 3, 4. These are the 4 sp3 hybrid orbitals of this carbon. From 4 sp3 hybrid orbitals, 1 sp3 hybrid orbital, that is overlap with the another sp3 hybrid orbital of other carbon atom. So that result in the formation of head-to-head overlapping, that result in the formation of sigma bond. And the other 3 sp3 hybrid orbitals overlap with the 3 hydrogen, that is a 1s orbital of 3 hydrogen overlap with the sp3 hybrid orbital of this carbon. So it results in the formation of a head-to-head overlapping. So there is a formation of a sigma bond. So this is about this carbon. Similarly, it happens in the other carbon also, that is this carbon. In this carbon also, there are 4 sp3 hybrid orbitals. From the 4 sp3 hybrid orbitals, these sp3 hybrid orbitals will overlap. That is, one will overlap with the sp3 hybrid orbital of other carbon, and this hybrid orbital overlap with hydrogen, that is 1s orbital of hydrogen. So it results in the formation of sigma bond due to the head-to-head overlapping. So finally what we can say, the structure will be in this way. So total how many bonds are there here? All bondings are actually head-to-head overlapping. That is a result of head-to-head overlapping. So here there is a formation of sigma bond. Here there is a formation of sigma bond. So like this. So total how many sigma bonds are formed? That is number 1, 2, 3, 4, 5, 6. Total 6 sigma bond, that is CH sigma bond. That is between the carbon and hydrogen, that is CH sigma bond, and there is one CC sigma bond. So when we make the structure in this way, that is this bond is a CC sigma bond, and the 6 CH sigma bonds are there. So how we can find out the number of sigma bond here? So the carbon-carbon bond is that is CC sigma bond. C sigma bond, because it is between the two carbon atom, that is CC sigma bond, and there are 6 CH sigma bond. CH sigma bond, that we can represent like this, CH sigma bond. So there are 6 CH sigma bond. So in this way we can find it out the number of sigma bond in the molecule also. Next, ethene. Ethene, in this the formula is C2H4. In ethene molecule, the two carbon atoms that are take as a central atom here. Let us write down the ground state electronic configuration of carbon, that is 1s2, 2s2, 2p2. 1s, we are not taking the use of 1s2 because it is not taking part in the hybridization. So we will be writing only 2s2 and 2p2. Now one of the electron from 2s get excited to 2p orbitals. So we will be getting in this way. Now here it undergoes sp2 hybridization because 1s and 2p orbitals are involving in the hybridization. How we represent the hybridization? By making the dotted box which is made here. So when you look at carefully here, how many orbitals are involving in the hybridization here? That is 1s and 2p. So that is the hybridization, sp2 hybridization. So each carbon in ethene is undergoing sp2 hybridization. So from sp2 hybridization, that is result in the formation of 3 sp2 hybrid orbital, that is 1, 2, 3. Now this is not called as s or p, it is called as sp2 hybrid orbitals. So there are 3 sp2 hybrid orbitals. How it comes 3? Look at here, 1s and 2p. Therefore, that is result in the formation of 3 sp2 hybrid orbitals, because here there is the intermixing of 3 atomic orbital, that is 1s and 2p. Therefore, it results in the formation of 3 sp2 hybrid orbitals. So what is the geometry for this? For 3, the geometry is trigonal. Now look at the structure here. Trigonal, that is represented here in the form of pink color. That is trigonal. It's a trigonal geometry. Similarly, the other carbon atom is also undergoing trigonal geometry. So that is represented here. So this is the trigonal geometry of this carbon, and this is the trigonal geometry of this carbon. So there is a trigonal geometry, trigonal planar geometry for both the carbon atom which is undergoing sp2 hybridization. So that is actually marked here in the diagram, that is in the pink color. Now from these, one of the electron that is not participating in the intermixing here, that you can see here, this electron. So this orbital, it remains as it is, that is which is represented here in the form of green color. That is, you can see here, this is actually unhybridized orbital. Unhybridized means the orbital which is not taking part in the hybridization. Which is the unhybridized orbital here? This is this one. So that will remain here with the carbon atom is in the form of unhybridized orbital. And why that is made in dumbbell shape? Because it is one of the p orbital. So p orbital is in the dumbbell shape. So that you can show here, can be seen here clearly. This one is the unhybridized orbital, that in the diagram it is represented in green color. So once again I will tell here in the diagram, this pink color which is shown, that is the sp2 hybrid orbitals of carbon. Similarly, this is the sp2 hybrid orbitals of other carbon, that is a trigonal geometry. Here, one of the orbital with electron is not taking part in the hybridization, that is called as anhybrid orbital. It remains with the carbon as it is in the form of dumbbell shape. That is represented here in the green color. So that is the for this carbon and for this carbon. Now from 3 sp2 hybrid orbitals, that is here from 3 sp2 hybrid orbitals, one sp2 hybrid orbital will overlap with the other sp2 hybrid orbital of the other carbon atom. So that result in the formation of head-to-head overlapping. So here there is a formation of sigma bond. Similarly, the other two sp, this and this, will overlap with the 1s orbital of hydrogen. It results in the formation of sigma bond, and this also results in the formation of sigma bond. So what we can say that from 3 sp2 hybrid orbital of each carbon, that is one is overlapping with the sp2 hybrid orbital of other carbon atom, and the two sp2 hybrid orbitals are overlapping with the 1s orbital of two hydrogen atom, result in the formation of sigma bond. So when we make the sigma bond in the structure, so we can say that there is how many sigma bond here? One sigma bond here, one sigma here, here, here and here. So total 5 sigma bonds are there. That is 4 CH sigma bond, that is this one is a CH sigma bond, that is represented here. CH sigma, CH sigma, CH sigma, CH sigma, and there is one CC sigma, that is between the two carbon atom. So total how many sigma bonds are there? There are 5 sigma bond, that is 4 CH sigma bond and 1 CC. Why I am saying CC? Because between the two carbons, so CC sigma bond. So 1 CC sigma bond and 4 CH sigma bonds are there. Now, what about the role of the one of the orbit which is unhybridized here, that is a p orbit. It remain here with the carbon. You can see in the diagram, it remain in the carbon. So this actually how it overlaps, because for these two head-to-head overlapping is not possible, as we have already learned in the overlapping, that is these orbitals head-to-head overlapping is not possible because these two orbitals are parallel to each other. You can see these two are parallel to each other. So head-to-head overlapping is not possible. So they will do sidewise overlapping. So sidewise overlapping takes place here. It results in the formation of which type of bond? That is pi bond. So we can say that there is a single pi bond between the two carbon atoms. So when you make the structure in this way, so you can see that here between the two carbon atoms there are two bonds, that is one is the sigma bond and the other one is the pi bond. So in between the two carbon atoms there are two bonds, that is one is sigma bond, the other one is pi bond, and there are 4 CH sigma bond also. So total how many bonds are there? Count it out here. That is 1, 2, 3, 4, 5, 6. Total 6 bonds are there. From this, one bond is the pi bond and there are 5 sigma bonds. So this is the way how we calculate the number of sigma bonds and pi bond. So what it results that whenever there is a double bond, from this, one of the bond will be, that is sigma bond, and the other one will be the pi bond. So that will help you to find out the number of sigma bond and pi bond in the different molecules. So this is for the case of ethene, in which two carbon atoms are sp2 hybridized and one unhybrid orbitals will overlap laterally with the other unhybrid orbital, result in the formation of pi bond. Next, ethyne. Ethyne molecular formula is C2H2. Here the two carbon atoms are act as a central atom. So we'll be writing the electronic configuration for the carbon atom, that is ground state electronic configuration, that is 1s2, 2s2, 2p2. The 1s electron does not take part in the hybridization, so we'll be not writing the 1s electron, so we'll just cut it out from here. So one of the electron from 2s, that is paired electron, get excited or promoted to the 2p, vacant 2p orbital. So it results in the formation of the excited state, which is shown here. Now there are single electron in this way. So from this, one s orbit and one p orbital undergoes intermixing. So it results in the formation of sp hybrid orbital. Look at here, single s and single p undergoes hybridization. So there is a formation of sp hybrid orbitals. Here two atomic orbitals are combining, therefore two hybrid orbitals are formed. So what is the geometry for when there is a sp hybrid orbital hybridization? So the geometry is linear. So that is actually represented in the diagram, that is in the red color. This is the sp hybrid orbital, that is 2 sp hybrid orbital of this carbon atom, and for another carbon atom that also undergo sp hybridization. So that is also the linear, which is shown here. But there are two unhybrid orbital, that is the orbital which is not taking part in the hybridization, that is shown here. These two are not taking part in hybridization, that is called as unhybrid orbital. These are the two p orbitals which is not taking part in the hybridization, which is called as unhybrid orbital. So it remain in the with the carbon as it is in a dumbbell shape, because it is p, so it is dumbbell shape. That is represented here in green color. This is one unhybrid orbital and this is the another hybrid orbital. Similarly, for the other carbon atom also there is one unhybrid and this is the another unhybrid. So that is represented in green colors in the diagram. So from sp hybrid orbital, which is actually having linear geometry, that is this sp hybrid orbital is overlapping with the other sp hybrid orbital of the other carbon. So it results in the formation of sigma bond here, and one of the sp hybrid orbital overlap with 1s orbital of hydrogen, result in the formation of sigma. Similarly, here also there is a sigma bond. So total how many sigma bonds are there? There are 3 sigma bond. That is, one is the cc sigma bond and there are 2 CH sigma bond. So total 3 sigma bonds are there. But the unhybrid orbitals, which are 2p orbital here, that is actually will overlap sidewise. You can see this and this can overlap sidewise because these are parallel. So they will overlap sidewise. Overlapping is taking place here. So it results in the formation of pi bond. That is, in this way, this and this is parallel. So it results in the formation of sidewise overlapping. So that is result in the formation of pi bond. So what can be clear from this? There are 2 pi bonds here. That is, when we are making the structure in this way, there is triple bond between the 2 carbon. It shows that one bond is actually sigma bond and other 2 bonds, that is the other 2 bond are the pi bond. So we'll represent here red color. One is the sigma bond and the other 2 are pi bonds. So total 3 bonds are there between the 2 carbon. That is, one is sigma and 2 are pi. So whenever we will make a triple bond, So when we make a triple bond, what it means that one bond is sigma and the other two bonds are pi bond. So that you need to remember, triple bond, one is sigma, other two are pi. So from these three examples, what it is clear that the geometry, that is for a single bond, it is sp3 hybrid orbit, that is sp3 hybridization. For double bond, sp2 hybridization. For triple bond, sp hybridization. So let us do some problem related to this. But2ene. Let us find out how many number of sigma and pi bonds are there in this molecule. The structure of but2ene is given here. First of all, in order to do such problems, what you need to remember, for single bond, that is a sigma bond, and if it is a double bond, from double bond, one of the bond is sigma, the other one is pi bond. And if it is a triple bond, then one bond is sigma and the two are triple. That you need to remember here. So first of all, do this problem. That is, we need to find out the sigma bonds and pi bonds present in this molecule. So first of all, let us find out how many sigma bonds are there. Here, there is one single bond here, that is CH bond, that is a sigma bond, CH sigma bond. This is also CH sigma, this is CH sigma. What about this one? Here also it is single bond, that is between carbon and hydrogen, that is CH sigma bond. What about this one? This is also sigma, similarly here, here, here. So when you find it out, how many number of CH sigma bonds, C and H, between how many single sigma bonds are there? That is nothing but equal to the number of hydrogen atom here, that is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 CH sigma bonds. So that is, here there are 8 CH sigma bond. We'll write it here. There are 8 CH sigma bond. What about CC sigma bond? That is a single bond between the two carbon atoms. When you find it out here, there is a CC sigma bond. From double bond, one of the bond is sigma, and here also CC sigma bond. So total 3 CC sigma bonds are there. So how much number of total sigma bonds? That is 8 plus 3, that is equal to how much? 11. So there are 11 sigma bond that is found here. What about the pi bond? When you find it out, there is a single double bond here. So from this double bond, one of the bond is sigma, the other one is pi. So what we can say, there is one pi bond. So there are total 11 sigma bond and plus 1 pi bond. So that is equal to total 12 bonds are there. Out of 12 bond, 11 bonds are sigma and there is one single pi bond. So let us check this one. How many total numbers we got? We got, that is 11 sigma and we got 1 pi bond. So let us count the number of bond in this molecule. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So like this we got 12 bonds. So from 12 bonds, 11 are sigma bond, that is including CC bond and CH bond, and there is a single pi bond. So this is the method to find out the sigma bonds and pi bond in a molecule. Let us try the next example. This example. In this example, there is a triple bond. So definitely when a triple bond is there, if there is a triple bond, from this one will be the sigma and there will be 2 pi bonds. So that you need to remember, from triple bond, one is sigma, the other two are pi. And what about the single bond? All single bonds are sigma here. So when you find it out, the CH sigma bond in this is a CH sigma bond, this bond. So these are the CH sigma bond, that is a sigma bond between the carbon and hydrogen. So that is better way to find out, just to count the number of hydrogen here. So how many hydrogens are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogen, that means 8 CH sigma bonds are there in this molecule. So we can say there are 8 CH sigma bond. What about CC sigma bond? Let us find out the CC sigma bond. That means single bond between the carbon. Here there is CC sigma. I am using the different color. CC sigma is here, and from triple bond one of the bond is sigma. So I can better make sigma 1 here, and there is one more sigma here. So you can find how many total CC sigma bonds are there. That is 1, 2, 3, 4. 4 CC sigma bonds are there. So total how many sigma bonds are there? That is equal to 12. 12 sigma bonds are there, including 8 CH sigma bond and 4 CC sigma bond. What about the pi bond? When you find it out, the pi bond here, that is triple bond is there, so it means that there are 2 pi bonds are there here. So we can say there are 2 pi bonds, so total is equal to 14. So total number of bond is equal to 14. From these 12 are sigma and 2 are pi bond. Let us check our answer. That is 12 sigma and 2 pi we are getting or not. That is 12 here, 2 here, total 14. Let us check whether you are getting 14 or not. That is, count the number of hydrogen. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So like this we got total, that is equal to 14 bonds. From this, sigma bond is also there, pi bond is also there. That is 12 sigma bonds and 2 pi bond. So this is the way to find out the sigma and pi bond in a molecule. What about benzene? In the benzene, it is a cyclic molecule in which there are 6 carbon atom and 6 hydrogen. So first let us find out the sigma bond, CH sigma bond. There is one CH sigma. Similarly here, this bond is CH sigma, this bond is CH sigma. So there are total 6 CH sigma bonds. 6 CH sigma bonds are there. What about CC sigma bond? When you find it out, here there are alternate single and double bond. Alternate single and double bond. So that means this is a single bond. So that is a sigma, CC sigma bond. From here, double, one of the bond is actually sigma, and here also sigma bond, sigma bond, sigma bond, sigma bond. So total how many CC sigma bonds are there? That is 1, 2, 3, 4, 5, 6. There are 6 CC sigma bonds. So total 12 sigma bonds are there. 12 means 6 is this is the CH sigma bond, and there is 6 CC sigma bond. So these are the total number, which is equal to 12 sigma bonds are there. What about the pi bond? Because here 3 double bonds are there. Each double bond, one bond is pi. So that means here there is one pi bond, here there is one pi, and here there is one pi. So total 3 pi bonds are there. So when you make the sum of this one, we'll be getting that is equal to 15. So total 15 bonds are there. Just now we'll check it this one whether we are getting total 15 or not. 15, that means 12 is sigma, 3 is pi bond. So let us count the number of bond in this. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we are getting total 15 bonds, including the CH sigma bond, CC sigma bond, and CC pi bond. So 3 types of bonds are there in this molecule, that is CH sigma, CC sigma, and CC pi bond. So total 15 bonds are there, including sigma and pi bond. So these are the which I have told here, that is the method to find out the sigma bond and pi bond in this. So what you need to remember, single bonds are sigma, double bond, from double bond one is sigma, one is pi. If it is a triple bond, one is sigma, two are pi. So on the basis of this, you need to find out the number of sigma and pi bond present in the molecule. So in the similar manner, you can find it out the number of CC sigma bond, CH sigma bond in the following molecule. Here in this case, it is condensed form. So you need to expand this hydrogen, like it is CH3 it is given. So better you can write like this. CH3 means this carbon have 3 hydrogen. So there are 3 CH sigma bond here, and similarly here also this carbon have 3 hydrogen. So better you will expand this one in this way. So that will be more easier to find out the number of sigma bonds and pi bond present in the molecule. So this is all about the important concept, that is hybridization of alkane, alkene and alkyne we discussed here. That is sp3 hybridization in alkane, sp2 hybridization in alkene and sp hybridization in case of alkyne. And we also learned the number of sigma bonds and pi bond which can be calculated when a structural formula is given to us. So this is all about this video. Have a nice day.